Are you aware of any effective methods to fight off antibiotic-resistant pathogens? The number of antibiotic-resistant microorganisms continues to grow. They are becoming a serious threat to global public health, and every year, only in the United States, antibiotic-resistant bacteria and fungi cause nearly 3 million infections and cause nearly 36,000 deaths. The situation is serious because no new antibiotics have been introduced into treatment for several decades. In the fight against them, it is worth to focus on the differences between the mammalian and pathogen cells. One of them is the difference in the transport of transition metal ions, such as zinc ions, and my work is exactly focused on the proteins involved in its transport. My name is Kinga Garstka, and during my doctoral studies, I focus on characteristics of the zinc ion transport mechanism in Aspergillus Fumigatus. I suspect that upon invasion of the host cell, Aspergillus Fumigatus secretes a protein, xenophore. The ASPF2 protein binds the free or bound to other biomolecules host zinc and then returns to the fungal cell and delivers it to the fungal pathogen through a physical interaction with the ZRFC transporter. I started my research using fragments of the ASPF2 protein. They showed that the selected sequences bind zinc but also nickel ions, which are another essential nutrients for the bacteria and fungi, and can theoretically displace zinc ions from its binding sites. The C-terminal fragment of the protein binds metal ions most strongly. However, the obtained results allow me to confirm that the zinc ions are bound by this region of the protein with the highest affinity. In addition, zinc ions are able to displace nickel ions from this binding site. At physiological pH, metal ions are bound by the same set of donor atoms, 2 histidine imidazoles and 2 cysteine thiols. I was able to identify which fragment of the ASPF2 protein binds zinc with the highest affinity. And now I will focus on the research involving ZRFC transporter fragments. These studies will allow me to check how exactly the transport of zinc ions looks and will allow me to answer the most important question. Could a fragment of ASPF2 protein serve as a targeting molecule linked to a drug substance? If you have any questions, please write to me. You can use this email address. You can also find more details about my work in this publication.